Martinez, and I'll be talking to you about gum found in sidewalks. First off, we can introduce this matter by understanding what is data. Data needs to be interpreted, analyzed, and collected through statistics. This matter can facilitate some of the world's greatest problems or issues regarding facts or numbers. Among some of them, we can include gum littering. Did you know that about 50 million people around the world chew gum, and most of them, those gums, are disposed inadequately in urban areas such as streets, sidewalks, buildings. As we know, gum is a non-biodegradable, it's not biodegradable, and it's made of synthetic rubber that can only it sticks to a surface, and it only can only be removed or worn out. In this matter, we can point out some therefore, why not test a small sample in order to consider the whole population of gum littering? Like, for instance, let's take a region or town in Puerto Rico and consider the fact of gum littering in it. Therefore, I will be looking forward to taking the main town of Gurabo, and testing the main urban areas to see how much gum littering is there. See, these are the results. This would include the locations, the actual sidewalks, which are 50, and the amount of gum pieces found in this case is the sum of all gum pieces, which were 379. In this histogram, you can see in the graph that it's nearly normal, but there are some unusual behaviors in the edges. It's right skewed, and some bar plots are a little badly distributed in the graph. We can consider using that data, taking the mean, like adding all the pieces of gum and dividing it by the amount of locations you considered. Then you calculate the standard deviation, which would imply subtracting each amount of gum pieces minus the average, raised to the square. Results will then be added and divided by the total locations number, and then you take the square root in order to find the actual standard deviation. And once you have the mean and standard deviation, you can proceed on other testing methods, such as the C-score, the confidence interval, making a hypothesis test, which I will explain later on. You can see these are the statistical analysis made. First, we start with this mean, which is the sum of all pieces found divided by the location total number. This will equal to 379 divided by the 50, which is the number of locations, and it would equal 7.58 as our mean. The variance is taking the sum of xi minus x bar to the square divided by n minus 1. In this case, it's 652.18 divided by 50 minus 1 equal 1331. Then we take the from finding the variance, we can take the square root of it, and it would equal our standard deviation. Then we consider the confidence interval as point estimate plus minus the margin of error. As you can see, the point estimate is mean, and the margin of error is C star times the standard error. So we would take 7.58 plus minus the C star, and we multiply that by the standard deviation divided by the square root of the number of locations, which would give us a confidence interval total of 6.58 to 8.59. And then we would make a hypothesis test regarding H null new equaling 8 pieces of gum found, and H alternate equaling new not equaling 8 pieces of gum. So we can test this as can proceed to seeing the sample being independent. It is random. It is the more than 30 tests were made, and it's less than 10% of population. So we find Z-score by subtracting the mean minus the number tested, which is 8, divided by the standard deviation, which is divided by the square root of 50, number of locations, equaling negative 0.81. And if we look in the table, it would give us 0.2090, considering that. And then, since we're looking at both sides of the graph, in the statistic manner, you would have to multiply that by 2, and would give us a total of 0.418, and 0.418 is bigger than alpha, so the null hypothesis cannot be rejected. These are the conclusions. After realizing a series of observations on results, we can conclude that the null hypothesis not be rejected, and therefore it concurs with of how it is a null hypothesis of nu equaling 8, concurring with the fact that the confidence interval is 6.58 to 8.59, evidently recording it as a 95% confidence interval, concluding it to the fact that the average number of gum pieces found in sidewalks throughout the urban areas of the town of Gurabo is between 6.58 to 8.59. Recommendations. I would consider more town areas, perhaps more county sectors, etc. Decreasing the amount of locations, maybe to 30 or 40 between that, and probably increasing the amount of space covered, since initially it was just a 2x2 box. Well, I would take a larger amount of space I would mark specific specific gum pieces found on the floor with bright colors or papers, and therefore I would compare also results from different times of the year or through different years, maybe a month, that maybe considering through different years in which that how it may increase or stay the same. Test that out. Concludes my briefing on gum pieces found throughout the urban areas of the town of Burao.